but I'll start by just briefly explaining a little bit about what One Acre Fund does. I'm not really going to be presenting about One Acre Fund itself today, but I think it's just a little bit of useful context for my following slides. So for those of you who aren't familiar with our work already, just very briefly, we serve over 1.3 million smallholder farmers in East Africa through an integrated service bundle, including financing for agricultural inputs like seed and fertilizer, delivery of those to within walking distance of farmers' homes, participatory training and market facilitation, which typically results in farmers increasing their yields by around 40% and increasing their household income by somewhere in the range of $100 to $150, which they then invest as they see fit in education, healthcare, more nutritious diets, off-farm business activities, back into the farm and so on. We also serve another 1.3 million farmers through government partnerships, but I won't go into any detail on that. And again, I'm not really here to talk about our operating models. Yeah, if you want to know more about who we are, what we do just check out our website. In terms of my role specifically at One Acre Fund, I lead a team which is really focused around the development of better recommendations in terms of products and agronomic advisory for farmers. And it's kind of a mix of soil science, agronomy, data science, behavioral sciences, trying to figure out how do we develop and package recommendations and deliver them to farmers in such a way that they are adoptable. I wanted to start with the question, how do we make R&D more farmer-centric? And asking perhaps, with the greatest respect to Norman Borlaug, is it time to update our motto a bit from take it to the farmer to a more precise start with the farmer? I can imagine there might be some eye rolling at this and the obvious question, isn't this just semantics? And honestly, I don't think it is. I often get approached by researchers who think they've already built a solution and now want One Acre Fund to roll it out to our farmer network, and they need to do it quickly because it's the final quarterly milestone of their 3-year project, not the first. That's a massive problem. Or to give another example, I get asked to provide letters of support for funding calls around novel applications of cute technologies like remote sensing, drones, smartphone apps, and machine learning to agricultural problems. And there's a place for that kind of thing, but we need to be really clear about what we're trying to achieve in that context. Is it a proof of concept for a novel tech application, or actually a scalable solution that adds real value to much simpler alternatives? And sometimes the distinctions between those two, scalable solution versus proof of concept, do not really seem to be clear to me in researcher or funder strategies, and nor are the pathways from one to the other. So, what do I mean by start with the farmer? I mean making sure that in the innovation process, we are focused on farmers' priority problems and finding efficient solutions to those that are actionable within their resource constraints. And that's really very different from developing a solution for one agronomic variable on one crop that you think is important, and then trying to get farmers to then adopt it. Particularly important here, given our focus on digital in this session, is the use of phones and access to phones, and I'll talk about that more a bit in a following slide. But even where you've got high adoption levels, you still need to think about who's got those phones, with what language and literacy skills, with what access to airtime and electricity and so on. And where those boxes are ticked in principle, what are farmers willing and able to invest in the process of getting better guidance? Maybe the advice is free, but there's no free lunch, right? They've still got to invest their time or some perhaps what they would consider personal information, use airtime or electricity to access that guidance. And I think we need to think carefully as well with this kind of proliferation of agronomic guidance apps over recent years, whether a smallholder farmer who grows maize, beans, potato, banana, coffee, cassava, multiple vegetables is really going to be willing to delete WhatsApp or some family photos to make space for an app which can confirm whether 1 or 2 particular diseases are present on their plot, or to spend time answering a detailed survey on their cropping history to get a fertilizer recommendation, Are they really going to be comfortable with you tracing their field boundaries, using some machine learning algorithm to track their productivity over time? And even if the answer to all those questions is yes, I think we still have to ask, is a fancy digital solution really the most efficient option? So I would really love if one outcome from me giving this presentation was that more researchers really focused on focusing on the problem and designing efficient solutions to those problems within farmers' existing resource constraints, wireframing those, getting them prototypes into farmers' hands as quickly as possible in the research process, and getting their feedback. And really sort of leveraging that Pareto principle that in many cases, 80% of the benefits will be in the 20% of the complexity and research that's needed to deliver that benefit. But we tend to get a bit caught up in the other 80%. So I wanted to touch briefly on this point about phone and smartphone ownership, because we often run into this assumption in the research community that mobile phones and even smartphones are ubiquitous everywhere, even amongst smallholder farmers. And for the markets that Acre Fund is serving, in East Africa at least, I'd say it's probably true that these devices are in principle sort of available everywhere, but that's not the same as accessible. So here's some data from our operating areas. This is a mix of our own data, some from the World Bank, some from ITU. And what we see is basically the ownership of even basic feature phones is still well below 50% in some places. And internet usage is in the range of 2 to 25%. The only country that we've got any reliable smartphone adoption data for is Kenya, and their smartphone ownership is in the range of 30 to 40%. And by the way, this is years behind really what industry forecasts were saying even 5 years ago. And it also doesn't tell you anything about the actual quality of those devices. We've been burned before when trying to develop solutions with mobile phone apps, finding that actually in many cases the functionality of those smartphones is really very limited because you've got a really old or fake version of Android, terrible camera quality, limited memory or processor capacity, poor GPS accuracy if it's even got GPS functionality, and so on. And so they're not necessarily all that much more useful than a feature phone. Oh, I can start my video, apparently. Can you see me now?
Yes, we can.
Okay, great, good. So yeah, all of which to say, like, yes, the future for digital extension is incredibly exciting, and yes, absolutely, it is a future that we should be building for. But I think there is a risk that we mistake the future for the present and miss out on some of the huge opportunities to deliver impact to farmers right now with simpler, much more traditional technologies that maybe aren't so reliant on digital, if reliant on digital at all. Just like paper-based decision support tools, radio, and yeah, also feature phone channels like USSD, SMS, IVR. So I think that the plea here would be that if we want digital information and channels to add value, again, we've got to start with the farmer, really understanding the populations that we want to serve and what their near-term digital capabilities are realistically likely to be. So how to use digital to add value? I want to talk here a bit about how we can actually leverage digital technologies. And the one kind of takeaway I want to drive home here is that digital information, obviously, I think we all know this, but we don't always act the same way. Digital information does not equate to adoption, and therefore digital information does not equate to impact. It's hopefully a really obvious point, but I think it's an oversight that often gets made where we think that farmers just having better information or knowledge will drive improved farm management and therefore higher yields or profit or whatever the outcome of interest is. But defining what the optimal action is, it's just one piece of a very complicated puzzle where we also need to ensure farmers have access to the resources they need to follow that guidance, be that credit or input accessibility or financing of some sort. There's some complicated socialization processes in there. Farmers might need some practical training to actually be able to execute that guidance, even if they intend to and are convinced by it. And then there's all these challenges around how we make actionable recommendations compelling and motivating for farmers to follow. Staying on that theme for a second. Oh, I've lost a slide. Good. Oh no, there we are. This is my attempt to apply the trans-theoretical model of stages of behavior change to agricultural extension. And the point I'd like to make here is that digital knowledge or information is obviously critical in that this is the whole ball game. This is where our recommendations are coming from, and therefore it obviously adds value to the extent of being the entry point into this process of behavior change, of getting farmers to follow a more optimal practice. But there are so many other enabling factors potentially needed to support farmers to execute on that information. And we need social marketing and extension interventions too to help farmers make transitions to following recommendations. And so all of that to say that whilst digital clearly has huge potential to help us develop more bespoke, optimal recommendations, and I'll be talking more about that in a few moments, we have to make sure that our excitement about that doesn't lead to us promoting really quite regressive models of extension, where as researchers, we're just kind of dumping information on farmers and leaving them to it. And 10 to 20 years ago, we'd maybe have thought about putting a demo plot near a bridge or close to a market to help farmers understand the impact of a new blanket recommendation. And I think we need to figure out what are our equivalents of that going to be when we're giving multiple different farmers within a small area different, even quite contrasting recommendations for each farm or even every field. And how do we support farmers to get used to that when they've been really used to kind of diligently trying to follow national recommendations like other good farmers do in their community. All right, so I'm going to move on now to talk about some of the stuff we've tried around sort of digitally enabled extension. Yeah, just to highlight here that for all my concerns about this stuff being done badly, it is an area that we see enormous potential for and that we're really progressively investing in more and more. And so, yeah, I'm just going to run through a few examples here of how we've been using digital and how that's going. So an area where we see enormous potential to improve smallholder farmer yields is through highly spatially specific real-time advice direct to the farmer in response to real-time crop and weather observations and forecasts. And the main thing we've made meaningful progress on here is sending farmers real-time guidance on May's sowing date, building off the TAMSAT alert system developed at University of Reading, for those of you who are familiar with that. And so in our operating areas, late planting is a major yield gap. And we think yield gains of around 8 to 12% are possible if we can shift late planters to more optimal dates. And the figure on the left here shows the average yields achieved kind of within our recommended window. So that's from sort of -10 to +10. Versus earlier or later on from thousands of crop cuts across our countries of operation over a 5-year window. And this is a great example of where digital can play a critical role because we can use remote sensing data to determine basically when a critical soil moisture threshold has been reached and is likely to be maintained in order to give farmers guidance on when to plant. And there's no scalable analog version of that. For this to work well, it's got to be delivered through digital channels because the guidance is very location specific and very time sensitive. So we can't be waiting on an extension agent to take several days to work their way through an area advising farmers to plant. We can't use radio because the geographic coverage would be much too coarse and so on. So using something like SMS is a very obvious way to deliver this advice in a timely and location specific way that just wouldn't be possible with more traditional channels. But that advice still needs to be part of a much bigger picture. So, for example, if you talk to farmers about what determines them making their decision to start preparing their field and get ready for planting, a lot of them will tell you that they're not going to do that until they're sure they've got access to inputs. So they've actually got their seed and fertilizer at home. So if we want them to be able to plant in an optimal window, we've got to make sure they've got those inputs in plenty of time ahead of that window. And we also need our field officers to do some work to sensitize farmers to the recommendations and give some context as to where they come from, which is really hard to do just via SMS. And we also know that farmers are less likely to trust guidance from SMS than guidance coming from their field officer. So we're trying to figure out ways to sort of leverage that FO farmer relationship to get more buy-in for these recommendations. One of the first areas we started exploring with SMS, with PXD, they also have been supporting us on the work mentioned in the previous slide, was around marketing of lime. And this table presents some of the results from a trial where the treatments and results for using SMS are in the sort of yellow cells. And then we're comparing those with results from a separate trial where the treatments and results are in that lovely beige color, where we used more traditional marketing channels to try and drive adoption. To be clear, these were two separate trials, so we can't really make very robust comparisons between the two data sets, but they do still give us some interesting comparison points, I think. So with SMS, we get some hugely encouraging results. SMS increasing Lime adoption by 5 to 6%, depending on the content or the framing of the message, which is an amazing improvement, incredibly cost effective. The bottom row here is showing the estimated SROI, that's social return on investment, which basically describes the additional units of farmer income generated per unit that one Acre Fund invested in delivering that recommendation. And so you can see these very, very high SROI values for SMS. But all that said, the adoption increases are about half of those that we achieved when training our field officers to market the product more effectively and incentivizing them for sales. And note also that in that context, field officers were dealing with a much tougher baseline adoption level of 2%. Again, we can't really directly compare these in a rigorous way. But I think it's likely that we wouldn't have seen a 5 to 6% adoption increase if the SMS trial had happened in an area where the baseline was much lower, because farmers would have had much lower exposure to the product to start with. We've got similar data from Rwanda also, which I'm not showing here, but we had a baseline adoption level of 5%, and we saw that SMS increased the likelihood of ordering Lime by less than 1 percentage point. That's not nothing, it helps, but it's clearly not a game changer either. And maybe it's because in that context, there was a lower baseline to build from. Or perhaps it reflects instead or also differences in population's responsiveness to this kind of digital guidance. So overall takeaway here would really be that digital extension can maybe be much more cost effective than traditional channels, but perhaps less effective overall in kind of absolute terms. Staying on the theme of Lime, another area we've tried to leverage digital information is use of soil data layers. So in this case, trying to use a 30-meter resolution map, which in theory should enable us to give us a field level recommendation. And using that, we're able to predict whether Lime application would be profitable with up to 55% accuracy. And honestly, that's obviously only better, sort of marginally better, really, than a coin toss. But when we take farmer-reported field characteristics and feed them into a classification tree, we get up to 76% accuracy. So in this case, we can systematize and sort of amplify farmer knowledge through some fancy sort of machine learning tools. And I don't want to give the impression that means that soil maps like this have no value. We're definitely finding multiple uses for them. But in both the case of developing Lime recommendations and also similar stuff we're doing around fertilizer recommendations, we're tending to find that farmer-reported variables are much more valuable predictors than the soil data layers are. And we're still trying to work on figuring out whether we can extract more value from both types of data when we combine them. Another area we've been starting to innovate around is delivering better maize variety recommendations to farmers. And again, spatial data here is key in terms of helping us understand which agroecological zones different varieties are more or less adapted to, but also which levels of environmental quality those varieties are suited to based on on-farm trials. So to illustrate that, on the right here, the blue dots relate to a variety that is better adapted to good quality environments, and so will be the best option in higher yielding fields. The red dots relate to a variety that's advantageous as the quality of the environment decreases. So it will be a better option in fields with lower productivity, be that in terms of field fertility or crop management. At the moment, though, we're only capable of determining the mega environment, so that's the kind of zone shown with this map on the left, based on the farmer's location. So that means we can kind of narrow down from a national level catalogue of many different varieties to just a few that will be appropriate in the local region based on the farmer's location. But we don't currently have any rigorous means of determining what the environmental quality of their field is. Again, we're expecting here that farmer-reported data, perhaps combined with some remote sensing data, may be the way that we can solve for that. So yeah, what I hope that those slides illustrate is that digital research and extension has to integrate farmer knowledge, not marginalize it. And I think it's really tempting for us as researchers to kind of let our egos ride this wave of rapidly expanding digital infrastructure and big data and think that it presents us an opportunity to kind of single-handedly fix farmers' problems by telling hundreds of thousands of them what to do at the click of a button. But there is just so much rich knowledge and practical know-how that farmers have as individuals and collectively about their local context that we don't have and probably never will. And there is enormous potential for us to combine that with the information that we do have to develop better recommendations. On that note, I'm going to give a plug for Jacob van Etten's talk later today on the tricot system, which I think is a really beautiful, practical example of the kind of innovation framework that can leverage and multiply the potential value add from both digital data sets and location-specific farmer insights to really advance our knowledge and ultimately deliver impact to farmers. Cool, so coming into land, this is my final slide. Just going to sort of run you through some key takeaways here. Number one, start with the farmer. Who are they? What are their digital resources? What support do they want? How, where, when? Find problems for solutions, not problems for your solutions. Then get prototypes and minimum viable products into farmers' hands as soon as you can in the product. You will learn so much from it. Information does not equate to adoption. Let's not fool ourselves that we can, as I say, just send farmers a message and they will just robotically do it. It's just so much more complicated. Digital platforms are uniquely placed to deliver time-sensitive or spatially specific guidance at really large scales, but we have to remember they may have relatively shallow impact if we don't combine them and integrate them within traditional extension channels. And I guess the next point is kind of similar. Finally, using digital to leverage local knowledge and enhance farmer participation in research and extension is really critical as opposed to just scaling advice from researchers. And I think this isn't really something I talked about, but probably an obvious point is that to pull all of that off, our research processes and frameworks and teams have really got to be interdisciplinary. I'm done.